Okay, here we have a discrete random variable question. Find the value of p. Well, we can do that by just noting that the four probabilities there must all add up to 1. So 3/8 plus 5/16 plus 4p plus 1p must all equal 1. Solve that, and we get p as a 16th. Great. Okay, part 2. Two values of big X are chosen at random. Find the probability that the product of those is 0. Well, first, just note what that means. If the product of two values is 0, then at least one of them is 0. So one of them is 0, or the other one is 0, or both of them are 0. So one way of solving this problem, I'm going to call it method 1, is just to list all the possible combinations of pairs of values that would cause that. Just backtrack a little bit there. Yeah, so you've got 7 possibilities there, both zeros, or the first one 0 and the second one something else, or the first one something and the second one 0. Common mistakes in this question were to either forget 0, 0, or to forget, just to list these 4. A lot of people just listed those 4 and they forgot that 0, 2 is different to 2, 0, so they didn't get as high probability as they should have done for their answer. So we just need to add up all of the possibilities now. Probability of getting 0 and then another 0 is 3/8 and another 3/8 multiplied together, 0 and 0. 0, 2 would be 3/8 times 5/16, and 2, 0 would be 5/16 times 3/8, so I'm just going to double that. Similarly, 3/8 times 4/16, that's 4p, and then doubled, because it could be 0, 4 or 4, 0. And then 3/8 times 1/16 for the last pair, doubled, again because there's 2 of them. If you add up all of, you do this plus this plus this plus this, and we get our answer, which is 39/64. Okay, there's a slightly more technically, mathematically interesting way of solving this problem. It's actually more efficient as well. I'll just show you that. Call it method 2. And that's to note that what we're trying to find is the probability that we get 0 first or 0 second. Now, or in probability can be represented using this union symbol. And when we've got it into that format, we can think about how would you normally calculate a union, probability of a union. Well, you can use this formula here, which is in the formula book. Probability of a union is the probability of one of those plus the probability of the other one, subtract the intersection. And I can show you why that works on a Venn diagram. The union, of course, is everything in these 3 regions here. And if you do the probability of A, so if you do the A region, which is sort of this bit here, plus the B region, which is this bit here, you'll see that we've double counted the intersection. So we need to subtract 1 copy of this intersection here, which is why we take away this. So it completely makes sense. So this union here, using the formula in black, we can write as probability that we get 0 first, then anything second, plus the probability that we get anything first and then 0 second. Subtract the probability that both of those happen, which is that we get 0 in both cases. So the probability of 0 and then anything is 3/8 times 1. Probability of anything and then 0 is 1 times 3/8. Subtract the probability of getting 0 twice, which we already did over here in the first method, and that gives us the same answer, 39/64.